Hello everyone. So this is my 469th day of LeetCode streak. Let us solve today's problem actually. Maximal rectangle. Given rows by columns binary matrix filled with zeros and ones. Find the largest rectangle containing only ones and return its area. So it is a simple problem if you have understood something like stack and also expansion. Let me tell you here till here, let's just see. Till here, the answer would be 1, right? Till here, it would be 1. Here also, till this, here, it would be 1. Till here, also, it would be only 1. One rectangle which is filled by all ones. All these in the row 0, 1 will be the answer. Now, let us stop at row 2, right? So, this will be a rectangle. This will be one rectangle. This can be another rectangle. This can be another rectangle. I am just taking the maximum one, which is nothing but 3 would be the maximum. Now let's stop at this row till here. I can take this 3 or take these 2 or take these 3 or take these 4 or take these 5 or take these 6. So here it would be 6. Now I am stopping at here. Now it would be 4 or it would be these 3. If you see, I am only considering the rectangles which touch or end with this row. I got 4 or I got 3. It is 4. From all these, the maximum is 6. But if you see, every time, let me tell you, if I have a 0 and then 1, wait a second, 0, 0, 1, 1, 1, 1, 1, 1, and then 0. So let's go like this, 0, 0, 0. Now, if you see here, at this row, I am talking about this row. If you see the height which I have starting with this row is here it is 1, here it is 2, here it is 3, and here it is 1. Now, let's wait for a second. Wait for a second. Now, when I am having 3 and then I have 1, it is nothing but this 3 is blocked, right? Let me tell you how does this work. Let me tell you, if I have a bigger number and then a smaller number, it is nothing but the blockage of expanding the rectangle, right? I cannot expand this rectangle further. Now, if I have 1 for one time, I can expand this here. I can expand this here, right? Now, if I have 2, I can expand this here, but I cannot expand this to 1. That's where the problem is. Now, this one can be expanded here, here, and also here. Now, if it is all zeros, can it be expanded here? No, not at all, right? So that's why I'm considering about expanding the rectangle starting from the left. Now, let us see how does the algorithm or intuition works. Now, let me tell you, I have 1, 2, and then 3. When I have this here, sorry, it is 1, right? It is just 1. Now, when I have this 1, when I have this 1, which is lesser than 3, let me tell you 1, 2, and then 3. Now, I have 1 which is lesser than 0, 1, 2, 3. These are the indices, right? Which is lesser than 3, right? Which is lesser than 3. It is just nothing but increasing 1 and then 2 and then 3, but suddenly I got 1. Now what I would do, 3, I just remove this one. Let's just write 3 at index 2, 2 at index 1, 1 at index 0. Now if I just remove it, if I just remove this index 2, then what is the index I got? It is just nothing but 1, right? It is at here. Now what I would do, I'm just telling you the intuition here. So for this 3, it cannot be expanded or extended further. So what I would do is I would just take only this rectangle into consideration. Now, that's why when I removed it, I got 2, which is at index 1. Now 3 minus 1 would give me 3 minus 1. The current index is 3 minus 1. 1 is nothing but the index before our rectangle, right? 3 minus 1 is 2. But the width is only 1, right? So 3 minus 1 would be the width. What I just did, let me write it clearly. Let me write that clearly. Wait again, let me increase the size. Right. So first, if I have increasing, then push, right? If there is decrement in the order at current index, then pop. Nothing but the top element is just removed. Then pop, and after that, what I did, the top element is considered as the left, the index considered as left. So, and left is top, top in. Let me just say that it is a stack, and left is top, and right is current index. Now width, that's it. Width is equal to right minus left minus 1. Now what is the height? What is the height? Height is nothing but this 3. 3 here, 3 here is nothing but the element which I removed. The height of the top index which I have removed, right? So before going with the width and removing, I need to, if there is decrement in the order at current index, then I said just remove it. So before that, I need to take height. Height is equal to, I think they have given as heights as, yes, height is equal to heights of st dot top. I think it's clear for now. If I have increasing, then push into the stack. If there is a decrement in the order at current index, which I am iterating, height is equal to heights of st dot top. Now, then pop, nothing but the top element is removed. So here I am just storing the indices. Let me write that also. Now, in the stack, store the indices, right? If I have increasing, then push. If there is decrement in the order at current index, height is equal to heights of st dot top, then pop, and left is top in stack, and right is current index. Now width is equal to right minus left minus 1. Now I think you have understood how I am taking this, calculating the area, right? Now let me just take or make this example big, right? So let me take this for 2 more times. Now let us see what will be now. Okay, now I have the height as 3 here. Wait a second, here it is 3, and also here it is 3, and here it is 1. Okay, now the stack, let me do a dry run at this row. At this row I would do this stack operation in every row, right? But I am stopping at this row. Actually the matrix will be looking like 0 0 0 0 0 0 6 times, and 0 0 triple one triple one 0, and then 0 1 1 plus 1 till here. The height is 2. The column height is 2 2 2, and then 0 1, and then here 2 1 and 1 2, and then here 3 3 3 and then 1. Okay, I think you got it how I got 1 2 triple 3 and then 3. Now let's go 1 2 triple 3 and then 1. Let us go with 1. The stack is having something like in, let's start with indices 0 1 2 3 4 5. So 0 1 2 3 4. Now when I went to 5, when I went to 5, here 4 is having a height of 3, right? So the height is equal to 3 and right right is equal to, what is the right? Right is equal to 5. And what is the left? I need to remove it and I got left is equal to 3. 5 minus 3 minus 1. 5 minus 3 is 2 minus 1 is 1. 3 into 1 area for now is 0, but I got 3 into 1. 3 into 1 is 3, which is greater than the area, right? So a max area. Now I have removed it. Now I got 3. Let me check again. Let me use another. Okay. Now I have 3. At 3, the height is again 3. So the height is 3. Right is equal to 5. The same thing where I am. Now the left is, I will remove it and then the left will be stacked top. Left is 2. Now 5 minus right minus left minus 1. 5 minus 2 minus 1 will be 2. So 2 into 3 max area is 6. Now I would go to 2, which is having a height of 3 again. Right is equal to 5. It's the same thing. And I would remove it. And the left is equal to 1. Now 5 minus 1 minus 1. 5 minus 2 is 3. So 3 into 3 is 9. That's how you update. Then again, I have 1, which is having, you know, greater height than the current element. Now it is having 2. So 2 wait a second, it is having a height of 2. Now height is 2 and right is still 5. Now left is equal to, when I remove this index, then the left will become 0. Now it has become 0. 5 minus right minus 0 minus 1, which is 4. 4 into 2 is 8, but 9 is greater, right? So here it has considered this one. I think you got 4 into 2, this one, right? I am at index 5. I am at index 5. I have got only those rectangles which are before index 5. I think you got it. Now to get the rectangles which stop at index 5, I'll tell you how we do it. Now, so if I remove it, I have index 0, but before that I would be having minus 1 pushed into the stack. Right now, let us let us go again. Now I have index 0, which is having the height of 1, which is the same as the height at index 5. Now what is the height? Height is 1, right is equal to 5, left is minus 1. So 5 minus right minus left, minus 1 minus 1 again. 5 plus 1 minus 1 is nothing but 5 plus 1 minus 1 is 5 into 1. The height is 1. The height is 1. If you see, every time I am taking the height, here it is 2, here it is 1, here it is 3, right? So that's why if there is increment in the height, then only I'll push back into the stack. If not, I'll just pop from the stack, right? So 5 and 5 into 1 is 5. That's how you get this one. Wait a second. This one as the rectangle which is ending. Now what I'll do, as I said here, how do I get it? So to get that, I'll just push back 0 at end of every row. So to solve this completely, I need to create a vector of vector int which is having a size, let me name it as mat n comma m plus 1, and everything is initialized as 0. M plus 1 is nothing but columns are the same, but there is a 1. This is called sentinel or senator. I don't know what does that mean, right? So n comma m plus 1. Now what I did every time, is going column wise and adding up, right? So if I have something like 0 0 1 1 and then 0 1, so this would become will be like 1 1 plus 1 2 and then 0. So I would stop here and then here 1. That's how you go through, right? So it will be building mat grid, right? Nothing but I'll be computing the height of every row. Now then after this I need to go through creating a stack of int where I will be having push minus 1, push minus 1. So I would go through every row. I would go through every row for auto row in a matrix. For every row, I would create a stack, an empty stack, and push minus 1. Then if I'll just iterate the current row if it is increasing, all right, if it is increasing, if increasing heights are increasing, push into stack, push into stack, else take current height is equal to heights of st dot top and left is equal to current index is nothing but I, right? Let me just say that as, sorry, right is equal to I, right is equal to the current index I, and left is equal to before, after removing from the stack I need to compute it. So taking the current height, then remove from the stack st dot pop, left is equal to st dot top, the index. Now the current height, or just update the max area is equal to maximum of max area, comma. How do I get the width? Just right minus left minus 1 into the current height, right? So it is if and then else. Okay, then this is how I get the maximum area, return the max area at the end. You can also write this in a separate function. That's how I did it. I'm just going through every row and calling for a function which gives the maximum area ending at that row. That's how you solve this problem. And if you have any doubts, if you see this is something like having a acceptance rate of 56%, you might be having so much of doubts. Please let me know in the comment section. Thanks for watching this video. I have given the link of the solution or the code in the description. Go and check it. Thanks for watching this video again, and please do like, share and subscribe to my channel. Thank you.